Alright, well, looks like we are live. So, let me get... Alright, well, welcome everybody. It is a little bit breezy, chilly evening here, but I think the breeze is going to die off, at least it's supposed to. So, yeah, we're going to see some more stuff. Haven't seen you guys in quite a while. I've just been broadcasting over at Night Skies Network and having fun over there, so haven't been on YouTube much, been a bit neglected, but I am back now. So let's turn off that. Okay, I'm going to do that, and I don't know if that's going to work. Okay, so now looking at Vega, the star I used to focus on, and I'm going to now pull up our Stellarium. I have 300 windows open that I shouldn't have open, and let's see, is Vega? Yeah, it's pretty well. Alright, we'll do this, and then we're going to go to the Ring Nebula, which is right next door here, and play with the Ring Nebula for a few minutes. Okay. And I didn't do this. Oh, I haven't started PhD, so this is going to fail, yes. I need to get this software going. I completely forgot about it. Boy, it's been a while since I've done the YouTube thing. Let's see, I need a different profile from that. Alright, you need to go away. And we need to do this, get that all guiding. Oh, you can see our ring right up there. Cool. Okay, so now I need to do this, and this. Okay, there's our little Ring Nebula right there. Okay, so we are going to... Where is it? Yeah, I guess it's right there, huh? Okay. Get that sequence started. And then we are going to significantly reduce the exposure time because the Ring Nebula is really... And before I did this, I really should have... centered this up because it's not in the center of the screen. Okay, and now everything is going to fail. And now I need to reset this. And I actually don't really even need guiding anyway because we're doing such short exposures that we really don't need it. Okay, and we'll get this reset properly. Come on, up there, there you go. We can see our little Ring Nebula, which is a planetary nebula. It's just a little tiny guy. Oh, I know I need to get this started too. And planetary nebula is... it actually has, the name has actually nothing to do with planets. It's a bit of a misnomer. When William Herschel was first discovering them in the 18th century, he could see that they weren't stars. He could see that they were not point sources of light. And so they were obviously spheres or something. He knew that they were not stars. And so because one of the outer planets, Neptune or Uranus, I forget, one of them was just discovered, and this looked, you know, the planetary nebulas that he was finding looked a lot like them. He assumed that they were planets too, and so he kind of called them planetary nebula. but what they really are is the death process of a main sequence star, not like our own sun. Our sun will probably do something similar in about 4.5, 5 billion years when it goes through its death process. And what happens is toward the end of its life, the star, regular star like ours, begins to swell and it turns into a red giant. It begins to expand and expand and expand, and when it does that, its core then shrinks, and because the core has less gravity, it's smaller and has less gravity, it actually loses it doesn't have enough gravity to actually contain all of the gases that have just expanded away from it, so they just keep expanding outward away from the core of the star. But the core of the star is still burning, it's still lit, it's still ignited, it's not as hot as it used to be, but it's still burning and it's still light. And so what happens is that it illuminates, it fluoresces the gases that are expanding out away from it with tons of UV, which basically makes it glow. And so what you see is the expanding gases blowing outward due to solar winds and whatnot from that star, and it forms this pretty ring that we call a planetary nebula. And not all planetary nebula are the same shape due to different gravity stresses and things that are in the area of the solar system in question and the star itself. Some planetary nebula can be really strange shapes, so they're not all perfectly circular. Even this one isn't perfectly circular. You see, it's kind of ovalish, and but yeah, it's just a natural part of the death process that our own sun will likely go through in quite a while. Hey Mike, thanks for joining. Good to see you again. But there's I think we've discovered like 3,500 planetary nebula, so there's a lot of them around, and they're like different shapes, different colors. The colors will depend on the actual chemistry that made up the star. Not all stars are made up the same way, and so depending on the chemistry of the star itself and the light that it's putting out from the core that's left, they can be all kinds of pretty colors. This one's mostly blue and red, bluish green and red, but other ones are all kinds of different colors. All kinds of different colors. Let me should probably get the music started here. Yeah, I did turn it off. Okay. A little background music, and let me know if the background music is too loud or too whatever, and I can turn it down. No, Mike, is not a new camera. This is the same. Oh, actually, I guess I should say it is the same sensor. It's a 533 sensor, but it's instead of the ZWO version, it's the Player One version called the Aries, and so it is a new camera. I wanted to try the Player One version. I heard good things about it, that it was better than the ZWO cameras. That really hasn't been my experience. It's a cool camera, it works great, but I can't say that it's doing anything dramatically different than my ZWO 533 did. But it's a nice camera. So yes, it is new, sort of. We don't need to spend a lot of time on this, but it's pretty cool little star. And you can see kind of in the middle here what is probably the core star that is illuminating all of it. Now, my telescope is not really good at zooming in on things and getting high resolution, so there's some really high resolution pictures of this where you're seeing all kinds of cool stuff in there, but mine is just mine can, I mean, this is the full frame of my camera, and so this is how tiny it is in the field of view of my camera. And my camera is not a very big camera, it's only a 1-inch sensor, so it's far from a full frame sensor, and still Ring Nebula is tiny, you know, in comparison to what I can see. And most planetary nebula are pretty small because they're not very big and they're pretty far away typically. So okay. Suddenly my scrolling is not working here. I'm not sure why. Just needed to switch windows. Maybe it didn't think this window was the active window. Okay. That goes away. I think I need to get rid of some of these windows. Some of these windows need to go away. In fact, most of these windows need to go away. Okay. Now, let me see what... yeah, you know what I have also forgotten? It has been a while. I think I need to not have this be full screen. I need to, where'd you go? Yeah, I think I need to have this be smaller. Because I don't actually, if I remember right, boy, it's been a long time since I've been done a YouTube broadcast. I don't see, you guys don't see my full screen. I can only broadcast, if I want to stay at 720p, which is about the extent of what I can broadcast from out here in the middle of the desert, I have to keep, I can't broadcast my whole screen, so I think I need to bring that in a little bit. Let's see how that, unfortunately there's about a 30 or 40 second delay between what you guys see and what I see, so it's I have to make an adjustment and then wait and then see how it comes out, because I have a second screen here that I'm monitoring the broadcast, and so I have to wait and see how it comes out, and so it's a bit of a slow iterative process, but we'll use Ring Nebula to do work out all these kinks. And then we're going to go to something a little bit, well, fainter, but larger. But you can see it's a pretty cool object. Stretch it a little more here. And let me pull up Wikipedia. Yes. I'm going to see how far away it is. History, observation. Blah, 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 blah. Yeah, we already know that. Properties, 2,600 light years away. So it's not too far away. Okay, and let's go back here. Alright, that works. mark's about right. Go up a little more and in a little more. Alright, but I thought what we would do is probably go to the Veil Nebula next. The West Veil. Okay. Get the West Veil next. It's a pretty one. It's faint. It's not going to be as bright as what we're seeing here, but it's a beautiful nebula. The pixels in this camera are the same as the 2600, so they're 3.75, 3.76, something like that. Microns. Thank you. Yeah. Okay. And let's go up here to our West Veil. And we will take our sequencer and we will turn. We'll go to next target and send our scope to it. And we'll do a quick plate solve to center it up. Yeah, you can kind of see it right in here. Wispy. Okay. Let's start our imaging. Now this is the story of a different kind of star. What we saw before was the death process of a smaller, well, a normal star, a regular old star, just like our sun. And it doesn't do anything particularly spectacular. It grows into a red giant. Like I said, it puffs up and grows into a red giant. And actually it can grow so big that it actually consumes some of the inner, the orbits of some of the inner planets. Our sun, if it does go into a red giant, and it probably will, but if it does, it might even get so big as to consume the Earth. It might actually go out as big enough to be out at the orbit of the Earth. So, and then eventually it will, of course, blow its layers off. But that's what it does. It just kind of puffs out and then just keeps on going and puffs out and keeps on going. And so that's what you saw there with the Ring Nebula, where those layers headed out from away from the core, the still lit core of the star. All right, so here's a little bit of a wispy. It's a wispy, pretty thing. It's better with filters, but this one is still pretty good even without filters, and it's got the nice star right there next to it. So we will let this fill in for a few things while I explain what this is. This is one part of the explosion of a supernova. So at the other extreme of a star is the really big ones. And the really big stars that are many times the size of the sun, when they go, they blow up. They have a spectacular death called a nova or a supernova. And this is one of the wispy remnants of some of the gas blown off from the huge explosion from a supernova that occurred about 15,000 years ago. And if we look at my Planetarium software, we can look in here. And so you see this whole large area in here. This whole large area is the result of one star exploding about 15,000 years ago. There's so much stuff in here that the size of this is about 3 light years across. And a light year is like about 300 of our solar systems in diameter, in length. A light year is a very large place. So this is literally hundreds and hundreds of times bigger than our entire solar system from one star that exploded. And what we're looking at right now is just this one little portion here that's blown away from it. And so right now it's upside down, you know, from how we're looking at it here. In fact, I think I can. I don't remember my. Oh, there we go. Is that right? No. I don't remember the shortcuts. Let's see. It's upside. Well, it's upside down and backwards and everything else. So, is that right? Yeah. So that's how it actually looks to us, to our view with our telescope. That's how it actually looks to us, because the optics of my telescope inverts and reverses things. Yeah, so this is kind of the result of the other end of the death process of a star. So this is a really big, spectacular star that does this, and it just creates a huge explosion. In fact, when this thing blew, it probably could have been seen during the day here. So there probably would have been 2 stars in the sky in the daytime, our sun and this one as well. Because this one is also not more than, I don't think, a couple thousand distance. Yeah, see, this is only like 1,500 light years away. So it's even significantly closer than the other one was. So it's just stretch this a bit more so you guys can really see it better. It's not very far away, so it probably would have even been bright enough for us to see in our own sky. Again, with every adjustment I make, I have to look at the screen to see. I have to wait about 30 seconds or so to see how it came out, to see if my adjustments I made were worthy or not. But the pretty colors in that, the bluish green is oxygen and the red is hydrogen. So again, it's the chemistry of the star that determines what colors things are. This is kind of similar to the way the Ring Nebula was, with the blues and the greens, but that was primarily a bluish green. This one's a bit more of a mixture of the two. The best way to see this is with a nebula filter that basically knocks the star field way down and way back. So the smaller stars you don't see at all, and the bigger stars are way reduced, and the sky background is a lot darker. And the reason is because we're basically looking in right along. This is a band of the Milky Way, and we're right along the edge of it. See, there's another puff of it right here with some dark nebula and dust and stuff blocking, but that is the band of an arm of the Milky Way that we're looking right into. And so that's why the star field is so dense here, because we're basically looking right into an arm of the Milky Way galaxy. Probably most of these stars are in the background behind the Veil Nebula, but some of them are going to be in front. Certainly this bright one is going to be pretty close to us. Probably some of these brighter ones are. But that's why it's such a dense star field, and why a filter can help see this, because it knocks all this white light down and really leaves the nebula alone, basically. It doesn't enhance it, but it knocks everything else back, making it look like it's much brighter. Probably should mute my mic when I do that, but oh well. And it looks like my internet is up and down and in and out as always. But if I hourglass temporarily, know that I'll come back eventually. The price one pays for living in the middle of nowhere. Great skies, but not such great internet. Okay, let's see what Wikipedia has to say. It's a cloud, the Veil Nebula is a cloud of heated and ionized gas and dust in Cygnus. It constitutes the visible portions of the Cygnus loop, which is the whole circular area I showed you from the explosion. All of this is called the Cygnus loop because it's one big area. Oh, and we got a satellite that just photobombed us. Bummer. Well, we'll take a few more. See if it cleans up a little bit. It constitutes a visual portion of the Cygnus loop, a supernova remnant, many portions of which have acquired their own individual names and catalog identifiers. And yeah, so this is the west veil. This is the west veil here. This is the east veil here, and this is a triangle called Pickering's triangle. And a number of the other parts have their own names too. You know what? I'm going to start that over. I'm going to start that over. So we don't have a silly streak through it. The source supernova was a star 20 times more massive than our Sun, which exploded about 15,000 years ago. At the time of the explosion, the supernova would have appeared brighter than Venus in the sky and visible in the daytime. The remnants have since extended to cover an area of the sky roughly 3 degrees in diameter, about 6 times the diameter, 36 times the area of the full moon. While previous distance estimates have ranged from 1,200 to 5,800 light years, a recent determination of 2,400 light years is based on direct astrometric measurements. This was about 2,400 light years away. So the Ring Nebula was, what, 1,500 we said, so this one's about 2,400. Alright, second sub's going to come in, so the background's going to darken nicely. Boom. With everyone that comes in, the background darkens and the noise drops off. Hey, Mike says, it looks like the area below the nebula is denser with stars than the top. Is the bottom portion closer to the Milky Way? Show you more color levels. Yeah, let's. So basically, this is the west veil. So this one is closest to the horizon. But yeah, we can look and see. So yeah, the Milky Way kind of runs this way. So it's kind of neither one. Neither one is closer to the center. I think what makes the difference is that some of it has more dust and stuff obscuring this particular portion of the arm of the Milky Way. You can see it's denser over here, but it's definitely through here as well. But it sort of gets a little bit lighter in here. The stars tend to drop off a little bit. So, if you look in here, even in Stellarium, it's much denser here than up here. Probably because there's just more dark dust and dark nebula and whatever else up here that's just blocking some of the stars in the Milky Way arm that we're looking at. And down here, it's not blocking as many of the stars. So, What my color levels are? Well, there's two different ways of there's two different color levels. First, I have my camera color balanced, which is down here in image controls, which I don't know if you're going to be able to see this or not. Yeah, I think image controls you can. Yeah, you can see this. So basically, my well, you might not be able to see the outside of this. Wrong window, wrong window. So, oh man, why you keep grabbing the wrong window? Okay, so hopefully you'll be able to see that. Again, I can't tell with these adjustments for another 30 or 40 seconds to see if they're actually showing up correctly. But so my camera I have color balanced with 100 red, green 0, and blue at 250. And you know, those numbers are different from what the numbers you'll see in a ZWO camera too. So, so that's okay. You mean in the live stack? Okay, we'll go there next. So basically, because I have the camera color balanced, when I start live stacking, I don't really have to do much in terms of the live stack process, balancing the colors, because that's essentially when you click this. Oh, can you see that? You might not be able to see that. Let me. I don't think you can see all the way out there, though. Getting these windows adjusted is always tricky. But yeah, so basically, there's not much of an adjustment here with the colors, because I have the camera color balanced pretty well. So the curves, when I don't color balance, if I reset this, you know, they're not very far apart. So a color balance doesn't make much adjustment because I have the camera itself color balanced with the settings that I showed you before. And the saturation I have is basically at 1, which I could, you know, we could have a little fun, turn that up a bit. That would certainly make things pop a little more. But yeah. Hey John, thanks for checking in. We're taking a look at the West Veil Nebula, which is a supernova remnant. So gases and dust that are glowing and that are left over from a huge star that exploded about 15,000 years ago. And then Mike was asking about my my color levels on the camera. So I think I will. In fact, I think what I want to do here is kind of do this. Yeah, determining how to color balance something. It's the color balancing itself isn't very difficult. Basically, yeah, I mean, I can send you a little. I can send you a little thing, but basically, you take an image of it. You just start live stacking, and you take an image, and you touch the color balance, and you touch the color balance button here, and you watch how these move. If it moves up, then that means you need to increase the number in the camera balance controls. If it goes down, you need to reduce the number. So if both red and blue goes up, which is normal for me, then you have to increase the numbers on the color balance. Then you reset it, see what the next one does, and then keep doing that until basically when you hit this, it doesn't do much, and that's when the colors are about right in your color balance setup. But yes, if you send me a PM, I think I actually have a written procedure. I try and write procedures all the time. I'm going to go to full screen here. And I try and write procedures all the time. Oh, wow, that expands beyond. I don't remember that doing that. Huh. I always write everything down because I forget the procedures. I mean, with things like color balancing, I don't do it that often. So by the time I need to do it, I've forgotten what all the steps are. So I should be able to send you what I have written on the written up for that process. But that's basically it. You know, you take an image in the live stack and see where the things go, make the adjustments in the camera controls, which I showed you initially, which is down here, image controls. And so you'd make the, if red went up, then you'd increase this number. And if blue went up, then you'd increase this number, et cetera, et cetera. And then you'd reset the stack and see what the next one comes in and how much do you need to adjust. Do they still go up? If so, add a little more. Are they going down? Then maybe you did too much. So you just got to go back and forth with it. Yeah, I really like the Veil Nebula. It's so pretty. It's so fine and wispy. This is also called the Witch's Broom, by the way, which you can probably see why that got its name. But yeah, it's just such a beautiful nebula. The other side, the East Veil, is not as bright as this, so I don't like doing that one without a filter, which would, like I said, will knock the background down and bring the nebula itself out to see it better, because it's much more subtle than this one. But this one is nice, even running with no filter like I'm doing now. Yeah, the darks and the flats. That's a good question. I'm still scratching my head over that one, because I color balanced this camera, and then I took a new, or actually no, on my 183 color, I color balanced it one night, so it was coming out great. Then I took a new set of darks with those settings, and then I come out the next time to use it, and the color balance is way off again, like I hadn't adjusted it in the first place. So, but then I'm hearing from some people that the color balance, the darks shouldn't affect color balance. So I have no idea. I still haven't gotten my head around that, quite honestly. I don't actually, you may have noticed in here, I don't actually use darks with the 533 anyway. All I use is hot pixel removal, and that's enough. With the 533, 2600, 6200, etc., that whole family of sensors, you really don't need to be using darks. With the 183 and the older sensors, absolutely. You can't have too many calibration files with those noisy old cameras. But with the 533, you don't really need to use darks on the 2600, etc. And so I stopped using them. And actually, they come out better. I mean, when I use darks, I still get hot pixels on the screen. If I haven't done the darks like very recently, I'll still get hot pixels. And when I turn off the darks and use nothing, the pixels go away, and that's not really, I don't really notice a big difference. So between using a good set of darks and hot pixel removal only, I don't notice, the only difference I notice is that I don't get hot pixels with the hot pixel removal. The darks don't seem to have a substantial impact on the image. So yeah, I have stopped taking darks and using darks with the 533. With the 183, yes, and so that's where I discovered the calibrate the camera, then take a new set of darks with the new calibration settings. Then when I go to use it, it's off again. Like, it was off about the same as like before I had even color balanced it in the first place, which is just scratching my head. It's like somehow the darks are offsetting the color balance and returning it, like negating it or something. I don't know. It's I don't know about that. Yeah, I'm still scratching my head over that. I don't get it. But that is how you color balance the camera. And I'm beginning to think you color balance it, and you take your darks, and then you color balance it, and then you leave it alone. But I don't know. I have not pursued that yet, and I think I need to. I need to like get on the SharpCap forum and just get into a direct conversation with Robin about the behavior I'm seeing and why the darks in SharpCap are affecting my color balance. Because it's my understanding they shouldn't, but maybe I'm wrong. Quite possible. It's happened before. Hey, look at that! Another satellite bombing right through. Yay, satellites. Okay, well, I think we got a good little amount there anyway. Well, we might be with, I don't know, we could try a quick peek at the West Veil, but I don't think it's going to come out, or excuse me, the East Veil. I don't think it's going to come out nearly as nice as this. This is just really nice. We can kind of zoom in here and see some of this wispy goodness, especially the blue-green parts. It's just very, and this is, you know, you can see why they call it the veil. It's just really delicate and beautiful. And it's real stuff. It's just chemistry in action out there in the skies. Almost looks like a painting. Back off on the stretch a little bit. That might be too much, but it's a beautiful piece of our universe. Yeah, remove satellite trails. I have never successfully and consistently gotten that to work. So, I know there are people who swear by it and who love it. I have just not been able to make that work consistently. So, yeah, I don't know. Thankfully the breeze has stopped. It's just a nice cool night. Clear. Mostly dry, although the transparency is, we're getting a lot of onshore flow here, so it's the transparency is not great, but it's doing okay. There it is in all its full glory. It's just such a beautiful thing. And the star right in the middle of it kind of just makes it all worth it. And in fact, that's probably a big part of the star that's illuminating it for us to see. If we go over to the other side, which we can try real quick, it's not as bright, but we can go over there and give it a try real quick. And give it a try real quick. Yeah, you can see its wispiness right in there. Well, we'll take a couple of subs on this. But it's still beautiful, even though it's very faint. This one is definitely better with a filter, but we'll see what we can see. We'll take a couple of subs at it. Take a couple swipes and see. Yeah, Robin has done an absolutely awesome job with SharpCap. It's you know, it started off as a very simple little tool and has grown into what I think is the best piece of software for EAA that is out there. Yeah, just hands down, I think it's the best EAA software there is. if you're doing short exposure stuff. You know, there's just nothing better. Planetary work, etc. There's just nothing better. If you're doing longer exposure things, I think Nina then has a few advantages, but I don't do any of that. I'm not an astrophotography person, so I don't really go there. Yeah, see, we got this guy here, not as bright, but still actually showing up pretty nicely. So this is this part. This is what we're looking at here. This is all this part here. This is the western veil. So this is the other end of the explosion that has just expanded out and out and out into just this huge area of space from one star. All this matter, all this stuff from one star. It's really quite impressive. This is one of my favorite objects to view, I must confess. And we're going to see another one of my favorite objects too here in a bit. In fact, we'll probably go to it next. We'll take a few subs of the eastern veil here, and then we'll go to one of my favorite galaxies. In fact, I think we're going to do a succession of 3 nice big close galaxies, some of our local neighbors, and see some pretty stuff with them. And that will probably take us pretty close to an hour from now, which is, I think, about the extent of what I'm going to be able to do tonight. Is a couple of hours, 6 to 8 Pacific time, because at 8:30 we have moonrise. We still have a pretty large moon that's rising at rises about 8:30, which means about half an hour beforehand the sky starts to brighten and start losing contrast on the images. Yeah, M33 will probably be one of those, but that's actually not my favorite. The one we'll see before that is my favorite. But yes, M33 will be one of the ones we take a look at. One of the nice things I like about M33 is that it fits just nicely in my field of view. So it's a pretty nice object. I don't shoot many galaxies with the color camera. The monochrome camera really is what I use that for, mostly during galaxy season, which will be coming up here in a few months. Usually in the spring. We have spring and early summer. We have lots of galaxies, and that's when I go to my monochrome camera, because it's more sensitive and picks up more of their faint detail. But some of the closer galaxies are close enough and bright enough that the color camera does a good job with them too. So we'll see a few of them tonight here coming up. But once again, you see the incredibly thick star field here. We are looking right into an arm of the Milky Way. You know, if you look up ahead, up over your head tonight in the sky, and you're not in too bright a sky, which probably eliminates most people listening to this, but if it's not too bright and you see the Milky Way, the band of the Milky Way up there, this is what it's made of, all these stars. Millions and millions of stars. Most of them, like our sun, main sequence stars. Nothing special. But every here and there's some really big ones that do spectacular explosions, like what created this nebula. And it's just a beautiful thing. Yeah, well, that 18-inch Dob has got some pretty big focal length, so that's not surprising. Looks like my internet's bumping up and down again. But yeah, the long focal length in that means you have a pretty small field of view, even with a big sensor like the 294. Well, I say big. These days, in the era of APS-C and full-frame sensors, I guess the 294 isn't so big anymore, but it used to be the big gorilla. And but with such a long focal length, you're really zoomed into things. You'd look at some of these, some of the veil here, and you'd probably just be zoomed in on one particular section. You'd see a lot of detail in the wispies. My little imaging newt at 600 millimeters of focal length has a broader view. Like I said, about a degree across, just a little over a degree across. So it's good for the bigger stuff. When I want to go to small things, I use like galaxies. Like I said, I use the 183, which has smaller pixels and I can zoom in a lot more. So, alright, we'll finish this sub and then I think we're going to go to our first galaxy of the night. Oh, like, why is this is looking so totally upside down? And that's because it's upside down. Because I had everything warped around here. Okay, so we are where? We are, yeah, I'm over here. So we're going to have to do a meridian flip to go see our galaxies. And we're going to go all the way around to the Sculptor galaxy, which is one of my favorites of all time. Okay, so let's go say goodbye to the Veil Nebula. And let's go to Sculptor. And I'm going to have to make sure. We're going to do a meridian flip here, which means our scope has to flop all the way around the other side of the sky. So I just need to make sure we don't snag any cables. Everything's looking good. Gotta come all the way around. And basically almost point right over my head, so I'm going to put the light protector shield on it too, so I'll be right back. Alright, put the light shroud on it, which is kind of like a lens hood for the telescope, because it's basically pointing right over my head. Right over my head at the, so right over my computer screens and all that stuff. Alright. So I just don't want it to pick up any of that stray light. Trying to get enough focus travel to use my nexus. I've already cut 1 inch off the truss poles and still can't get back focus. Okay, and we'll synchronize on this. Yeah, this is one of my favorite galaxies. I think this is about 12 million light years away. 12? No. It's closer than that. Oh, now I don't remember. Getting them mixed up. Sculptor Galaxy. Discovered by Caroline Herschel. So this is the history of it. Features. I am not seeing it in here. Why am I not seeing it in here? Because we are not pointed in the right place. Okay, what is happening here? There it is. Well, I don't know why that first plate solves it. That sometimes happens. I don't know why. If a plate solve doesn't work correctly, and it actually sends it away from the object. I don't know why. Alright, so we'll start again here. The Sculptor Galaxy, blah, 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 only surpassed by, is the brightest galaxy in the group. Blah, 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 blah. Star formation. Distance estimates. 11 million. Looks like 11 million. Yeah. To 11. I wasn't that far off. Yeah, it's somewhere in the 11 to 12 region, which is, in galactic terms, is one of our local neighbors. The next two we will see are a lot closer, but this one is just so pretty. There's just so much detail going on in this that I just love seeing it. It is such a pretty one. Research suggests the presence of a supermassive black hole in the center of this galaxy, with a mass estimated to be 5 million times that of the Sun, which is slightly heavier than Sagittarius A, which is a very big black hole. So they're saying there was a star 5 million times that of the Sun. Yikes. 5 million times. That is just astounding. Discovered by Carolyn Herschel in 1783. Blah, 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 blah. Hubble took pictures of it in 1998. As one of the brightest galaxies in the sky, the Sculptor Galaxy can be seen through binoculars and is near the star Beta Cetae. It is considered one of the most easily viewed galaxies in the sky after Andromeda. It is, I think it is brighter than Triangulum, or M33 as Mike was saying earlier. I think it is probably brighter. But I think Triangulum might be a little bit bigger. But it's just, there's just so much detail in this. It's just so, I just want to zoom in and zoom in and zoom in on the thing. Like spending a little time on it, and it's just very pretty. And all these individual stars that we're seeing here obviously are in the very much in the foreground. They are in the Milky Way galaxy because we don't have any telescopes yet powerful enough to see, to resolve individual stars in distant galaxies. So every star you see here is way, way, way in the foreground, we're looking through some of the, some of the stars outside of our galaxy and seeing this in the background, because this is, these stars are dozens to hundreds, possibly thousands of light years away, whereas this galaxy is 12 million light years away, which also gives you some idea of the size of this monster. It's a very big galaxy. Yeah, it was probably smaller in mass from the prior. Yeah, yes, that's absolutely true. Black holes, of course, will gain mass because they're sucking everything into them. The original star wasn't 5 million times that of our sun, but the current gravity well that's generating it is. And so, based on all the stuff it has sucked in, it's grown to be that much mass. The Sculptor galaxy is a good target for observation with a telescope with a 300 millimeter diameter or larger. I think I'm supposed to say mirror, but they didn't put the word. In such telescopes, it appears as a galaxy with a long oval bulge and a mottled galactic disk. Although the bulge appears only slightly brighter than the rest of the galaxy, it is fairly extended compared to the disk. In 400 millimeter scopes and larger, a dark dust lane northwest of the nucleus is visible, and over a dozen faint stars can be seen superimposed on the bulge. Well, with a camera you can see all kinds of dark dust lanes, which is what we're beginning to resolve here. All kinds of detail. It looks very marbled to us as the camera continues to pull in more and more detail. Let's... Oh, have I even done that? No, I didn't even do that. Didn't color balance me. Okay, put you there. We can stretch you a little bit more. Make you pop a little bit more. Be easier to see. Just so cool to look at, and I just really love this galaxy. Triangulum and Andromeda are bigger and closer, but this just is so, I love the marbled texture of the dust lanes in this. And it's pretty low in the southern sky, so if you're in the northern half of North America or Europe, it's harder to see because it's down where you can see here where my horizon is here. So this is probably only what, 20 degrees up? Is that these 10s? Yes, these are 10s. So it's probably only about 25 degrees up for me. So the further north you get, the lower this gets. And so for a lot of northern hemisphere folks, it's hard to see. The bright streak on the left side of the galaxy, about 2/3 down. Wait, the bright streak on the left side of the galaxy, about 2/3 down. The bright streak. This one here, is that what you're talking about? Zoom in on that. It'll get pretty grainy as I zoom in. But yeah, that's probably, who knows, an area of dense star formation, a lot of high energy star formation going on in there. Again, we can't resolve individual stars in neighboring galaxies, they're too far away. But we can see globular clusters within them, collections of stars, areas of high energy density where they're typically reds or blues. They've got a lot of energy and a lot of chemistry going on. Time for a drink. I'm very thankful that the light breeze that was blowing when I was setting up did die off. They said it was going to, and I'm glad it did, because it was rather chilly. You know, I should look and see. Well, maybe one of you can look and see. Hey, Mike, when was my last broadcast on YouTube? It's been so long that I had to actually re-enter. I had to go get my broadcaster's key again from YouTube and put it in before I could come in, which is why I was a couple of minutes late tonight. I had to re-enter my key, which means either it probably changed. They probably updated it or something in the time it's been since I've broadcast here. But yeah, it's I ran into a couple of hurdles just simply because I haven't been here in so long. So I do like broadcasting on Night Skies Network is which is nightskiesnetwork.com, by the way, is a lot easier. It's a lot easier than YouTube, a lot less restrictive. Oh, something pinged at me, but everything looks good. It's just a lot easier there. It is not so much software to deal with. You know, I have to use Open Broadcaster Studio here to actually input my YouTube key in, and then Broadcaster Studio then has to send the broadcast to YouTube, because YouTube can't do it itself. Well, Night Skies Network just does it all itself, so it's a lot easier, and it's also looks like my internet's gone again. Yeah, I'm getting a 0 on the internet. Let me see if I I seem to be on the internet. I'm not sure why. Yeah, I don't know. Internet does what it does. OBS seems to be complaining that it's got no internet, but it seems to be fine here. I don't know. Don't know what you guys are experiencing. Maybe you're getting some hourglassing. Always seems to be a bit variable. But anyway, the Night Skies Network just makes it a lot easier to broadcast on. And also, everybody can speak. You know, if you have a microphone and speakers, you can talk on it. So you know, it's nice being able to chat that way. So that, you know, and it's a two-way chat, and so it's not just me talking and you guys typing in. It actually can be two-way chat, which is really cool. So there are a lot of things I like about it. The one thing I don't like about it is that there's no recording. So I would have to record locally and then upload, because there are no recordings of those broadcasts. So appreciate the star therapy. You're welcome. I'm happy to. I like doing it, so it's. I'm happy that. I mean, I appreciate that you're here. It's nice having someone here who's at least talking to me. It's a lot less interesting when I'm just talking to myself here. So, luckily, I'm very practiced at talking to myself. But it's nice having somebody who wants to interact. So. You do a fantastic job of explaining everything. Thank you. I see a few really faint companion galaxies. Oh yeah, I'm sure there are. In fact, let me do a... Well, kind of, maybe it'll just show up. Yeah, it just looks like it's just going to show up. Oh, I know. Yeah. I need to switch my catalogs. I have, the catalog. I only have them up down to the Mag 16 catalogs, and I need to switch that back. Okay, so to do that, I would need to. I would need to go. The catalogs are going to be in software, SharpCap. Yeah, but this thing, well, I have to get notes. Where are they going to be? It's going to be there. So I got to go in there. Boom, boom. So right now I have the 16 up here, and what I really want to do is get rid of that and put the 18 in, so that I can see much fainter galaxies. Oh yeah, that's not gonna work. I'm gonna have to change that. That is not gonna work. Yes, that is not gonna work. No, no, come on. M. Rename. I need this to go out. Yes. Okay. Now I should be able to go in here. Open this up. Go into display. Clear and reload. And then this should go. 16 should turn into 18. There we go. Boom. It just turned into 18. Alright. Yeah, now I've got a lot more galaxies. And you'll see that they're off. So which means I need to do really quick a plate solve only, which will then put them back on, and then everything should be circled right. There we go. There they all are. Yeah, so there are all the galaxies that are in the view that are down to Mag 18. They may or may not be companions. They're probably, the odds are they're probably not, but almost all galaxies have companions, especially sizable galaxies, and this clearly is a pretty big galaxy. So it probably has some companions. How many of them we can see or not, who knows? But there are definitely several in that view. such a cool looking galaxy. I really like this one. Whoa, what happened there? Dunno. Okay, so we will take one more sub on this and then we will move along and we will go do our Triangulum, our next galaxy, and this is going to be a lot closer, but not nearly as bright. Sculptor is one of our near neighbors, but it's still 12 million light years away. We're going to go to the Triangulum now, which is a little less than 3 million light years away, so it's 4 times closer. But it's not as bright and contiguous as the Sculptor. This is just a lot of interesting stuff in this galaxy here. Just so very cool. I like it. All right, there we are, Sculptor Galaxy. Where to go? Next target. So we'll move on to Triangulum, which is going to be up here. Right next to the Triangulum constellation. Boink. Alright, and we'll head up to that one. In fact, what I might do, actually is head over to, just real quick, let's head over to, Almach. Yeah, let's head over to Almach real quick, and I'm going to check my focus. I'm going to check my focus, because it's been a while since I've checked it. So let's go over and put it in the center here, and I will check my focus on this, make sure we're getting good stuff. Yeah, that was certainly good enough for me. Okay, let's go back over. So we will synchronize on that, and then we'll go back over to Triangulum, and we'll image that baby up. And there it is, right there. Okay. Center it up just slightly better and get it started. Like I said, this one's like a little less, I think it's like 2.75 million light years away, so it's quite a bit closer than Sculptor, but it's not as big. But because it's close, we can see areas of star formation and things in it that sometimes look red and blue. Especially if you're using some filters on it, which we are not using, but let's get it color balanced. And bring out some of this detail. There. It's a beautiful spiral. And some of these knots of high energy and star clusters and things will really start to pop after we get a few sub exposures in. It's if you're using a filter on this, it really the red and blue parts really pop out, but the stars don't show up as well because the filters cut back a lot of the white light, and stars are full spectrum objects, so when you put a filter on them, it cuts a lot of their light down, which is the point of using filters. Which is why I don't like using filters on galaxies, because they're obviously stars, and so you do end up cutting a lot of their light. But if you do use a filter on this galaxy, there's a lot of red and blue spots, which mostly show up as the brighter spots, brighter white spots in an unfiltered camera. So, but you definitely see some beautiful arms in this, and sort of a chunky detail. It's not as clean as Sculptor is. It's a bit, I don't know, sloppier or something. It doesn't have really well-formed arms, even though you can see that they're there. You can see that it's a spiral galaxy, but they're not. It's a little sloppier, a little messier than Sculptor is. Sculptor just has such a beautiful disk with all that marbling, with all the dark lanes in it. So it's my favorite. But this one is pretty cool looking too. And we're looking almost face onto this as well, so we get to see a lot more of how it's laid out. Sculptor, we're seeing much more toward edge on. options taken care of. Yeah, you can even start to see now some of these areas are looking kind of blue. And those are areas where there's lots of high energy stuff going on. Probably stretch this a little more now. No, you didn't want to do that. That might be a little bit too much. Yeah, that is the trick with astronomy. Contrast is king. Trying to see that object as bright as you can on a background that's as dark as you can get it. Zoom in a little bit more, I think. Still want to get rid of the outer wispy areas. So a little information about the Triangulum Galaxy. It's 2.73 million light years away. Also called Messier 33 or M33, as Mike indicated earlier. It's the third largest member of the local group, behind Andromeda and the Milky Way. So, it's the third largest member, but it's the smallest spiral galaxy in the local group. Although the large and small Magellanic clouds may have been spirals before they collided basically with the Milky Way, and the Milky Way kind of tore them apart and pulled a lot of their stars away from them, which helped the Milky Way grow. But the Triangulum is believed to be a satellite of the Andromeda Galaxy. And so it is actually circling the Andromeda Galaxy. I think it was probably discovered in 1654. And independently rediscovered by Charles Messier in 1764. Okay, well, there's 15 minutes on Triangulum, one of our nearest neighbors. So let's go now to the closest one, which is, of course, Andromeda. We're going to have to watch this. No, I need to center it up with the plate solve. Yeah, now we get its two brightest companions. And now we can Alright, now we'll start going on our nearest neighbor, which, as you can see from this line, is very close to the meridian. Which means as it crosses over, I'm going to have to watch and make sure my scope doesn't collide with the mount, because it's basically pointed straight up at it. Straight up in the air. So I got to make sure my back of my scope doesn't hit the pier. Mike asks if we can see Andromeda naked eye here in Tacopa, and the answer is yes. With averted vision, you can see it quite clearly here. Oh, you're referring to M33? No. No, I don't believe you can see M33 naked eye anywhere. It's my understanding. Let me go back to the... Whoa, look at that. I think we were still moving when that first image was taken. It's my understanding the only extragalactic object that we can see, the only object in the sky that we can see naked eye that is outside of our galaxy, outside of the Milky Way, is Andromeda. I don't believe even in Bortle 1 you can see Triangulum naked eye. Alright, let's get rid of that smeary image. Okay, what is happening here? Whoa. I don't know what's happening here. My guiding has gone absolutely bonkers. Okay, you know what that means? That means that, I have a feeling, that means that my scope is pointed too high. Why will you not start? It may be that the scope is pointed too high. I'll have to watch this. Okay, I need to reset you. Yeah, you are also going to be garbage. You're better, but I'm still going to delete you anyway. Yeah, we're just pointed so straight up that it's kind of a bad place to get on it. Very close to the meridian. In fact, I might even want to... I should have stayed on Triangulum for a couple of extra minutes. What else can we look at? Because we're not going to be able to stay on this very long. My scope is going to hit... It is going to hit the pier, so... Well, are you up high enough? Yes. We'll do something. And now for something completely different. We're going to come back to Andromeda once it has crossed the meridian. For now, we're just going to go do Pleiades. Let's see, yes, we're ready to go. We're going to go do Pleiades. We'll wait till Andromeda crosses the meridian so my scope doesn't collide with the pier, and you know, I liked it better the other way. There we go, yeah. I'll bring you back out this way. Liked you back down, better down here. Yeah, that'll work. Okay. We'll do Pleiades for a little bit until Andromeda has crossed the meridian. Pleiades is a fun one to do. Nice little cluster of blue young stars in a gaseous region that just really lights up nice and pretty. So this is basically a group of young white-hot stars that if you look up in the eastern sky, if you're here on the Pacific coast, in the Pacific time zone, it's kind of about halfway up from the horizon to the meridian. If you're more toward where Mike is on the east coast, it's probably pretty much straight up overhead. But it's a group of young, hot white stars. And the theory used to be that they just formed here, and the gases that they're illuminating, were the gases that they formed from. That this was a star-forming region, and the gases that formed them, they are now illuminating before they move out into space, and that's kind of how star-forming regions work. Stars are born and then slowly move out away from the big cloud of gas that formed them, and start their own lives, as it were. And so that was the original theory of what the Pleiades was this is where they were formed. But more modern theories seem to think that there's not enough gas here to really be a star-forming region, and so this just happens to be a young cluster of stars that did form together and are moving out into space, but they haven't spread out completely from each other yet. They're still pretty close together, and they're just moving through an area that has a bunch of gas in it that they are illuminating. So basically, this is reflection nebula, where this gas that they're moving through is just reflecting their light, and so we're seeing it reflected. And I think, if I remember right, that this is about 4,000 light years away, but I'm going to check that. Of course, the challenge is always spelling Pleiades, because it's 3 vowels in a row, P-L-E-I-A. It's an open star cluster containing B-type stars in northwest of the constellation Taurus, at a distance of about 444 light years. Boy, I was way off. Almost 450 light years It's among the nearest star clusters to Earth. It is the nearest Messier object to Earth. It is the most obvious cluster to the naked eye in the night sky. It is also observed to house the reflection nebula NGC 1432. It's dominated by hot blue luminous stars that have formed within the last 100 million years. Huh. Interesting. Above, they say, in the first paragraph, they say it's an open cluster containing middle-aged hot B-type stars, and then they say it's 100 million year old stars, which is very, very young. Anyway, reflection nebulae around the brightest stars were once thought to be leftover material from their formation, but are now considered likely to be an unrelated dust cloud in the interstellar medium through which the stars are currently passing. This dust cloud is estimated to be moving at a speed of approximately 18 kilometers per second relative to the stars in the cluster. Computer simulations have shown that the Pleiades were probably formed from a compact configuration that resembled the Orion Nebula. Astronomers estimate that the cluster will survive for about another 250 million years, after which it will disperse due to gravitational interactions with its galactic neighborhood. The name Pleiades comes from the ancient Greek, and they have it in a bunch of Greek letters, which I can't read. It probably derives from plane, P-L-E-I-N, to sail, because of the cluster's importance in delimiting the sailing season in the Mediterranean Sea. The season of navigation began with their heliacal rising. And I gotta go plug a computer in. Heliacal rising, however, in mythology the name was used for the Pleiades, the 7 divine sisters, the name supposedly deriving from that of their mother Pleione and effectively meaning daughters of Pleione. In reality, the name of the star cluster almost certainly came first, and Pleione was invented to explain it. Well, I know for us, for the modern day, it's the Japanese call the Pleiades Subaru. And like Mike, I just came back to the screen, and there it is. Mike already said it. So if you look at the emblem on a Subaru, the car, it is a star cluster that resembles this, and so they call it Subaru in Japan. We just call it pretty. It is a pretty cluster. Let's see. And let me stretch it a bit more. You guys aren't seeing all of it yet. Stretch the heck out of it so we get some more of that cloudy. Hey, thanks, Mike. I appreciate you being here. And yeah, send me the PM, and I'll send you my written thing for the process on getting the camera color balanced. As to how they interact with darks, I'm still scratching my head. So, but I can at least give you the procedure I have for for getting the balance done. All right, you come here. Why are you freaking out on me here? Yeah, so my guider is complaining because I have clouds moving in. So I think we are going to be able to do Andromeda, and that'll be about the end of it, which is perfect timing because I wanted to end around 8 o'clock Pacific anyway, since we're going to need to have the moon. The moon is going to be rising, so it's about time. So say goodbye to the Pleiades for now. Got a good little shot at them, and we'll go do Andromeda real quick, and then we'll call it a night. Because the moon is going to be rising, and the clouds are moving in, and so we're going to be done. Alright, where are you? There you are. Alright, we get to go around the horn this time. Now you're on the other side of the meridian. Make sure my cable's all guide right here. Yeah, that should be fine. Still going to be pointing up pretty high, but not so that we're going to be hitting anything, which is a good thing. Alright, look at that. There we are, close already. Okay, we still have the companions here, which is good. So let's start pulling some subs. And it looks like pretty much straight up the clouds are not there, but the whole northwestern sky, northeastern sky is gone. The eastern sky is gone, which is why the Pleiades were starting to complain, because the wispy clouds are starting to get there. But hopefully we'll have at least a good 10 minutes or 15 minutes on Andromeda. Not that we really need that, because it it's a very bright object, so it doesn't take much time. Color balance it. Oh, get this straightened away. Come on. Bring you in a little bit. Clear you. Where's my light? This is the Andromeda Galaxy. Oh, hey, Jeff. About 3 years ago, now I measured most every clear night. Well, thanks, Jeff. Thanks for the kind words. It's good to be a force for good and not evil, so I appreciate that. I like that I inspired you. I really enjoy doing this stuff, so it's nice to share it, and it's one of the really nice things about EAA and doing things on the computer is that you know, then you can broadcast and share it with others. So it's nice to show folks what's out there and that they can do it too. It's not complicated to do this stuff. Well, okay, that's a lie. It is complicated to do this stuff. There are many. You have to wear many hats. It's the culmination of a number of disciplines, not only astronomy and astronomy gear, but also electronics and computers and networking and software configuration and camera and optical skills. I mean, it's a combination of a lot of different skills to make this all come together, and so it's not necessarily trivial to do, but it's for those who have all those skills, or at least are willing to pick up the ones they don't currently have, it's very rewarding. And you don't have to broadcast, you don't have to do all that stuff. You can just get yourself a camera and just do it for yourself at home. And you know, it's just when you stick a camera in the eyepiece of your eyepiece holder of your telescope, the focuser of your telescope, and take a look at what it can see compared to what your eyes can see, it's just, there's no comparison. It's a whole other level. So yeah, it's just it's a lot of fun. I really enjoy it. And but yeah, there are nights where things go wrong. You know, tonight it had been so long since I'd been on here. My broadcaster software had either lost my YouTube broadcast key, or the key changed in the year plus it's been since I've been on YouTube. So I had to, you know, that's why I was a couple minutes late. It was 6 o'clock and I was trying to get in, and I couldn't get in because my software, my broadcast software, needed the key, and it was an outdated key or something. It must have been outdated. So just lots of things that can go wrong. There's a lot of plates in the air, a lot of technical things, but it's a lot of fun when you can see the stuff that's out there and share it with others. So it's I'm really glad to hear that you were inspired and are now doing it for yourself, and hopefully you're also showing others, even if it's just, you know, just outreach, even if it's just your family. Hey, come out, take a look at what I got on my screen, you know, whatever. Or setting up on the sidewalk and letting neighbors watch. Great way to do a neighborhood activity. Yeah, it's a lot of fun doing this stuff. It's work sometimes, but it's fun. And of course, like any hobby, the gear grab is endless. It's a bottomless black hole of things you can buy and money you can spend. But yeah, it's just really a lot of fun. So this is Andromeda. This is the only object that we can see naked eye that is not in our solar system. Excuse me, not in the Milky Way galaxy. Every other thing that you look up in the sky and you see at night, stars and clusters and all sorts of things, all of that stuff is inside the Milky Way galaxy. And if you get a dark enough sky, like Bortle 3 or darker, this is one object that you can see naked eye, and it's the only object outside of our Milky Way that you can see naked eye. And it's just our local sister galaxy, the Andromeda Galaxy, only about 2.25 to 2.5 million light years away, which in galactic terms is nothing. A lot of the galaxies we see are hundreds of millions of light years away, so this one only being a couple million light years away is really close. And I think the theory is that we are actually on a collision course with it, and possibly in another few billion years we're actually going to collide and probably tear each other apart. The interesting thing about galaxies colliding in space is that there is so much distance between the stars in a galaxy. I mean, you look at this galaxy and it looks like just one solid mass of stars, right? Billions and billions and hundreds of billions of stars. But, like, you know, look up in the night sky. How far away is the nearest star? Like all galaxies, this one has so much distance between all of the individual stars that when galaxies collide, it's extremely rare for any physical bodies to actually collide, for two stars to actually physically collide. So when two galaxies collide, there's not so much a collision as their gravity wells simply tear each other apart. And so they're actually called active galaxies, where you can see there's a couple of galaxies close together, and they've pulled each other apart into these weird, amazing shapes and things. And so that's the way galaxies collide. It's really gravity that causes them to quote-unquote collide and misshape and affect each other. But even though there's hundreds of billions of stars in each, they really tend to not collide with each other. The galaxies physically pass through each other, and their gravity wells tear themselves apart. So kind of an interesting thing. It's just because especially when you look at a galaxy, you know, we've looked at three fairly large close galaxies tonight, and they all look like they're just this massive blob of stellar matter. It just, you know, it's like, it doesn't look like it's mostly space, but it is. It's so far away that all the stars are so close together, look so close together, that, you know, we think that it's all one blob of material, but this is just hundreds of billions of stars that are really, really far apart from each other, that are being seen from such a distance away that it looks like it's all one mass. And gravitationally speaking, it is all one mass, which is why it stays together and swirls and has a shape and has companions. You know, these are two of its companion galaxies, M32 and M101. And so those are satellite galaxies that are orbiting the parent galaxy of the Andromeda. And the Triangulum Galaxy that we just were on, our second to last object here, the last galaxy that we were on, that is believed to be a satellite of this Andromeda galaxy as well. So gravitationally they really affect each other strongly, but physically there's just so much distance between each individual star and each individual thing that they don't they circle each other and they tear each other apart with gravity, but they don't really physically collide even when they pass through each other. Kind of a wild thing. Yeah, and I think we're going to time it just about right. That cloud bank is on the north. I don't know if it'll ever come down here, but at this point it doesn't really matter because the moon is going to be rising here in about 20 minutes, which means the sky is going to, even now, the sky is getting imperceptibly lighter and lighter and lighter, so that we can't see quite as much of the background sky that gives us all that wonderful contrast. To see the object, this background sky will get lighter and lighter and lighter as the moon continues to rise. But again, you can see, like we could with Sculptor, you can see the dark lanes and the dust lanes in here. The galaxy is bigger than my field of view. My field of view is only about 1 inch tall by 1 inch wide, a little over, and so it's probably like 1.5, 1.7 degrees from corner to corner, and so it's I think it's 2.5 or 3 degrees in total size, so it's a lot bigger than what I can see with my 1 inch camera, but it's enough to see some of the detail and some of the dark dust lanes. And it's just, again, not as interesting as Sculptor was. Sculptor with all those marbled dust lanes in it was just, I just love that galaxy. This one is a bit more plain, but it's bigger and it's brighter and it's still spectacular to look at. It's our sister galaxy. Good old Andromeda. And it is a pretty cool binocular target too. So, because it is big and bright, it's a pretty cool thing to look at in a pair of binoculars. You won't see this much, obviously. It'll be a much dimmer, fuzzy smudge, but it is something that can be seen with binoculars. You know, the last 3 or 4 objects we've looked at, the Pleiades is a great binocular object. This one's a good one. Triangulum and Sculptor are good binocular targets. So, Veil, the Veil Nebula, one of the ones we looked at early, was, you know, that is a big enough target to be great for binoculars, but it's just so faint that it takes a sensitive camera and some exposure time to to be able to pick it out. You know, I'm using 60-second sub-exposures to capture these images, so, you know, holding the shutter open on a very sensitive electronic sensor is much more, many orders of magnitude more sensitive than our own eyes. So it's almost like cheating. But looks like it's about 36 out here right now. So I think the clouds moving, it might warm it up a little even. But yeah, I'm really thankful that the breeze stopped. When I was setting up, it was a little breezy. I'm glad that stopped, because that would have been miserable out here with a breeze and this temperature. But it's turned into a beautiful evening. Almost perfect for astronomy till the clouds started moving in. But that's okay, because the moon is gonna be, well, the moon is coming as the moon is rising now. Probably, I think, in another 15 minutes or so, around 8:30. So that will definitely end things. I think I'm probably just going to end here anyway. It's a good spot, nice spectacular object to do it on. So yeah, I think I'm going to go pack it in and go warm up inside for a bit. So thank you everyone for being here, and hope you enjoyed the show, hope you learned something, and if nothing else, I hope it inspires you to get outside and look at the sky if you can yourself. I know for most folks, you're living in urban and suburban areas where it's really hard to see much of anything, but take a pair of binoculars out. You never know. You can see. They help punch through light polluted skies a bit. And but yeah, just get out and take a look whenever you can, because it's amazing beauty. But yeah, well, thanks Jeff, and thanks everyone for being here, and I will catch you guys next time. Thanks everybody.